Explore the number of teams Y remaining in a single elimination tournament can be found using the exponential function y is equal 128, 1.5 in exponent x, where x is the number of rounds played in the tournament. Determine whether the function represents exponential growth or decay. Explain. If we are looking at this function here, and we already know the general form of this function is a times b in exponent x plus c. And in this case, the base b is 1.5. So in fact, let me write this in decimal numbers. So it's 0.5. But this 0.5 is less than 1. Because it's less than 1, according to definition of the exponential function, we already know this is an exponential decay function. So this function is a decay. Okay. In a b, what 128 represents in this function? So 128 is equal to a, so this is a scaling factor, 128. And usually it represents the vertical stretch or compression in the exponential function, but in this specific case and real world situation, 128 represents the number of the teams that participate, is the number of the teams that participate here. And x represents the rounds. Already it says the x represents the number of the rounds. So this information here, we need this information for later. So now let's go in and see what percent of the teams are eliminated after each round. Okay. So let me go here a little. And if we are going here, now if we are going here to find out the number of the team, we already had this function, so just let me rewrite again. So y is equal to 128 in exponent 1.5, 1.5 in exponent x. So b, we already know b is equal to 0.5, 1.5 or 0.5. So let me write in a decimal number. But according to the decay, to the exponential decay model, we already know b is equal to 1 minus, so let me raise this, so it's b is 1 minus r. And now we are looking for the percentage. R represents the ratio, or the rate, or it represents the percentage. And now b is 0.5, and I want to solve this equation for r. So let's say b is 0.5. We already know is 0.5 is equal to the 1 minus r. Everything here we are subtracting by 1 both sides, and this we can cancel, and this implies r is going to be minus r, in fact, because here is minus r, is equal to the 0.5 minus 1 is a negative 0.5. If we are multiplying both sides by minus 1, so r gets is equal to the 0.5. But this is a numerical value. If we want to convert into the percentage, then we just multiply 0.5 by 100%. And what we get, r is equal with the 50%. So is a 50%. So it means after each round, 50% of the teams are going to be eliminated. So this R what means. R means that after each round, the number of the teams is going to reduce for 50%. Okay, now let's go this graph of the function. What is the reasonable domain and the range of the function? Okay, so let me go here in this one. Okay, so let's graph the function. So just let me rewrite again this function, what it was. So y was equal with 128, 1.5 in exponent x. So just let me rewrite the general form of exponential function. General form of exponential function is written y is equal to the a in a b in a x plus c. Okay, but c here is a missing. And to find the c, I already here, I just can add a 0. And it satisfies this equation, and it satisfies the definition or the general form of exponential function. And now, first of all, to find one easy way to sketch the graph of the function is if we find, for example, the horizontal asymptote. Finding the horizontal asymptote is equal, y is equal with c, or in this case c is 0, so y is equal with 0. So already we know the horizontal asymptote of exponential function is right here. So y is equal with 0, so this is a horizontal asymptote. And the second thing we find here is exponential growth or decay. We already know this function is exponential decay function because we answered previously, and we know the function is going to be decreasing. And the third thing what we need to know is the y-intercept. And if we want to find the y-intercept, we set the x is equal to 0. And now y of 0 is going to be equal 128 times 1.5 in exponent 0, which is going to be 128. Anything in exponent 0 is 1. 128 times 1 is 128. And the y-intercept, we already see here, is a 0 and 128. So let's imagine here is 128 somewhere, okay? And so this point is a 0 and 128, this point here. And now graph of the function is going to be this way. Okay, so is going to be this way. Approximately, we are sketching. So something like this. And now we want to find the reasonable domain and the range. We already sketched the graph of the function. Now we want to find the reasonable domain and the range of the function. So if we are looking here, for example, in the 0 is a 0, 128. But now if we have the first round, okay, if we have a first round here and if we are applying in this equation here, but we already know 50% of this team are going to be eliminated, but in the first round is going to be eliminated. Even if we can do analytically, we plug it here 1 and we get here a 64. Okay, so but because we know the half of the team, there were 128. When they play with each other 24 against 24, we get 64 win, they stay in the game, and 64 they go home. So this is in the first round what's happening. In the second round, what's going to happen, the 64 are going to meet with each other. And in second, so 30 team are going to play against 32 team, and 32 is going to win, but 32 others, they're going to lose, so they're going home. And this is 1, 2, 3. And in the third is a half of 13 here is a 16. So they are going with the same idea. And in the fourth, 16 team when they play with each other, 8 team against 8 team, 8 win, and 8 lose the game, so those who lose game go home. In the fifth round, the 8 team they play with each other 4 against 4, 4 win, 4 lose, so the winner stays. And in the sixth is going to be 2 by 2, so is a quarter final. So this is 6, and here is 2. And here is a semi-final, and a final is here. In the final, just one team wins. So after the 7 rounds, just one team is going to win the game. But if we are looking for the domain here, so domain, the reasonable domain is in the x-axis, so it's a 0, 0, 1, 2, 3, 4, 5, 6, 7 rounds. So domain represents the rounds, 7 rounds, but the range represents the number of the team, how many teams they were. And if we are going, for example, from this position to up, we are going to see is going to be 1, 2, 4, 8, 16, 32, and 64. So those are domain and the range, and domain and the range are a discrete domain and discrete range, but those are the reasonable domain for this specific case. Those are domain and the range, discrete domain and the range for this specific case in the real world situation.